Chapter 14, Gas Law Equations. Boyles' Law. In 1662, that's there just to give you an idea of when the scientists came up with these ideas, but you do not have to know the dates. What Boyle did is he said that gas pressure was inversely proportional to volume. So when one goes up, the other goes down. Temperature is held constant, meaning they didn't allow temperature to change. In his experiments with pressure and volume, he discovered that they were inversely proportional, and he was able to come up with the calculation P1 times V1 equals P2 times V2. So volume times pressure in the first case will equal volume times pressure in the second case. You can see from the little schematic here that when you increase pressure, what's happening to volume? It's decreasing. You can think of it as a stress ball. You have the stress ball in your hand, you close the stress ball, exerting pressure on the ball, and the ball gets smaller. Volume is decreased. Charles did experiments on volume and temperature. He kept pressure constant, so pressure is not in his equation. What he discovered is that volume and temperature were directly proportional. So as one went up, the other goes down. And this brought up the idea is what happens when you get to zero? Well, when you get to 0 degrees Kelvin, you have zero volume. You might remember we talked about absolute zero, where they believe, theoretically, all molecular motion will stop. So our equation is V1 over T1 equals V2 over T2. You should realize that this equation looks different from Boyle's because Boyle's was inversely proportional, Charles is directly proportional. Sometimes students have trouble solving for a variable that's in the denominator. If you happen to be one of those students, keep in mind that you can cross multiply and rearrange this equation so it's V1 times T2 equals V2 times T1. It's the same exact equation. We were talking about 0 Kelvin or absolute zero, which brings up the concept that in all gas law equations, anytime temperature is to be used in the equation, it has to be in Kelvin. So usually you're given Celsius, so in this case you would take your Celsius temperature that you're given and add 273 before putting it into the equation. Now sometimes they give you Celsius and they ask for Celsius. You still cannot use it. You have to change it into Kelvin, put it in the equation, and then you simply subtract 273 to get it back to Celsius. Gay-Lussac is our third and last scientist who did experimentation, and the third variable he kept constant. So he didn't let volume change. He did pressure and temperature experiments, and he found, just like Charles, that they were directly proportional. So you have P1 over T1, P2 over T2. Keep in mind, same thing, you can cross multiply. P1 T2 equals P2 T1. Whatever makes you makes it easier for you. Gay-Lussac allows us to talk about some real-world applications, which is a pressure cooker. A pressure cooker seals the food inside and increases the pressure. So in this case, we increase the pressure. What does it do to our temperature? It increases temperature, and our food can cook at a faster time because it's cooking at a higher temperature. The combined gas law contains all three of these, so you don't have to memorize three separate equations. If temperature is constant, you leave it out, it's Boyles' law. If instead pressure is constant, it's Charles' law. And if volume is constant, it is Gay-Lussac's law. So you only have to memorize one equation, the combined gas law, which says what if all three variables change? P1 times V1 over T1 equals P2 times V2 over T2. Easy enough equations.